Wait for a Starship static fire and two come at once. I think there's a saying along those lines. Lockheed's inflatable space station module pops like a balloon, Stoke Space fires its engines beyond 100% power, and how do you test a car for autonomous driving on the moon? We'll have all of that and more coming up this week in Spaceflight. This week there was a lot of moon-related news, starting with an update about iSpace's lunar lander. The lander, named Resilience, is currently on its way to the moon for iSpace's second Hakuto-R mission. It ticked off an important milestone by performing its last deep space maneuver ahead of lunar orbit insertion. Resilience launched atop a Falcon 9 on January 15th alongside Firefly's Blue Ghost lander. As you probably know, Blue Ghost successfully touched down on the moon in March and completed its mission with flying colours. So what's taking Hakuto-R so long? It's going the long way round, taking a so-called low energy transfer. This trajectory requires much less propellant to reach the moon at the cost of taking a very, very long time. It's getting closer though. Along this journey, iSpace has plotted 10 milestones, which the company calls successes. By completing the deep space maneuvers, Resilience has now ticked off the 6th of these successes. The next step of the mission is lunar orbit insertion, which is expected on May 7th. The lander will then hang out in lunar orbit for nearly a month, with the landing in the Mare Frigoris scheduled for June 5th. While Hakuto-R was on its way to the moon, we saw another mission play out from launch to landing, the IM-2 mission from Intuitive Machines. The lander, called Athena, was launched by a Falcon 9 on February 26th and was quickly followed by its landing on March 6th. If you followed along, you'll know that unfortunately this didn't happen as planned. It landed 400 meters from its targeted landing site and fell over after touchdown, much like its sister lander on IM-1. The lander's suboptimal orientation meant that Athena's solar panels were unable to generate power, so the mission was over very quickly. But Intuitive Machines and NASA worked to get the most out of the mission's main payload, the Polar Resources Ice Mining Experiment 1, or Prime 1. The goal of the experiment was to figure out if materials on the moon could be used in future lunar missions. Instead of the planned 10 days of operation, the Prime 1 experiment got just 10 hours, but that was just enough to fire up the two instruments, a drill called Trident for digging into the lunar surface, and a mass spectrometer to analyse the drill's cuttings for gases that might be useful for generating propellant or breathable oxygen. Both of the instruments started up pretty much immediately after landing. Teams on Earth commanded the drill to rotate, extend, perform a hammering motion and turn on its heater. All of this worked well, but NASA doesn't actually state whether it actually drilled into the moon. The lander's sideways orientation may have made that impossible. Meanwhile, the mass spectrometer scanned for gases. It did detect some, but researchers believe they were all carried to the moon by Athena. They might be vented propellant or water vapour from Earth, so if Trident drilled into the surface at all, the other instrument didn't observe anything from it. In total, Athena sent back 6.6 gigabytes of data, and while it's hard to call this mission a success, NASA is happy that it was able to at least verify that the Prime 1 equipment worked. In more news from Intuitive Machines, the company announced this week that it has performed self-driving tests with its Lunar Terrain Vehicle, or LTV. Intuitive Machines leads Moon Racer, a team of companies, universities and institutions that jointly develop this LTV. The team pictures the rover as a way for future Artemis crews to explore the lunar environment, but they also envision the rover being useful between missions when there's no crew to drive it around. To make this possible, the LTV can be operated by an astronaut, but it's also capable of driving on its own. No human required. The team tested this ability in the Rockyard at NASA's Johnson Space Center, which is a simulated lunar environment filled with all sorts of obstacles you would expect to find on the lunar surface: craters, boulders, loose soil, etc. The Moon Racer prototype managed to navigate these hazards using software provided by Australia's National Science Agency, the CSIRO, which employed a LiDAR system to map the vehicle's surroundings. Last month, the team put the LTV through its paces during a series of tests involving NASA astronauts. A previous round of similar testing resulted in a list of feedback that Intuitive Machines has now implemented. Among other things, the latest iteration of the vehicle allows for easier crew ingress and egress and more streamlined science operations. The Moonracer team hopes to be selected to fly the rover on a demonstration mission for NASA's Lunar Terrain Vehicle Services program. Currently, 3 companies are in the race for that contract: Intuitive Machines, Venturi Astrolab, and Lunar Outpost. NASA plans to award the demonstration mission by the end of this year. NASA wants the first astronauts to use the rover on the Artemis 5 mission, currently scheduled for 2029, but it should have been roving around on the lunar surface on its own for a while before then. We also got some space station news this week, but we'll have to hang out near the moon for a little longer for a story about Gateway. NASA and its international partners are planning to launch this station as part of the Artemis program into an orbit around the moon. As you may know, the station's first module is the Habitation and Logistics Outpost, or HALO for short. It will be launched in 2027 on a Falcon Heavy, together with the power and propulsion element that provides the station with power and propulsion. That's if they're not too heavy. That's a whole different story. HALO's primary structure recently arrived at Northrop Grumman's facility in Arizona, where teams will soon begin final outfitting and installation of all the equipment to make it a fully functional space station module. With all this paraphernalia installed, HALO is then set to undergo verification testing. NSS Adrian Beil recently travelled to Italy to the facility where HALO was constructed to speak to some of the people involved with the program. We did that in a previous episode of This Week in Spaceflight, so go check it out to learn more about HALO and why NASA needs a station like Gateway. In a video released this week, Lockheed Martin's inflatable habitat blew up into thousands of pieces. But there's no need to worry, it was intentional. Inflatable modules like these are popular in modern space station concepts, and it's easy to see why. They fold up into a relatively small package for launch and then can be inflated into a spacious living quarter. It's a very effective way to provide more room for activities without having to launch a traditional metal pressure vessel. It has already been proven to work with the beam module, which has been attached to the ISS since 2016. But just because you want it to inflate like a balloon doesn't mean you want it to pop like one. That would be a very bad day. So Lockheed Martin has been testing subscale prototypes to make sure they can handle their design pressures. Previous tests in 2022 and 2023 showed that the structure can handle 253 psi, or nearly 6 times its maximum operating pressure before bursting. For the latest test at NASA's Marshall Space Flight Center, Lockheed Martin performed a so-called creep test at 4 times the design pressure to determine the long-time strength of the material. This started as a 100-hour test, but the module lasted 4,177 hours at pressure before bursting. That's 174 days, or just shy of half a year. CAS Space is also working on inflatable modules, and recently they fired a gun at their micrometeoroid shield. This shield will protect CAS's Large Integrated Flexible Environment Space Station module, also known as LIFE. Previously, CAS has tested LIFE with burst tests, just like Lockheed Martin. In 2022, they successfully passed 2 subscale tests of LIFE, which passed NASA certification requirements. After that, they did a full-scale burst test showing it can handle all the safety margins. CAS is working on these modules under the Unfunded Collaborations for Commercial Space Capabilities 2 initiative, or CCSC2, which was awarded to them in June of 2023. Not only does the award provide support for a Pathfinder station, it also allowed them to use NASA's White Sands testing facility in New Mexico for the recent test. The shield is made from a high-strength flexible fabric material called Vectran. To test this material, CAS and NASA fired a 50 caliber 2-stage light gas gun that replicates micrometeoroids and orbital debris. The first stage uses gunpowder, and the second stage uses extremely compressed hydrogen that will speed the projectile up to 7 kilometers per second to mimic orbital debris in near vacuum-like conditions. Aerospace fired a total of 59 projectiles at the micrometeorite shield to confirm it can withstand the impacts. With the material now validated, the company plans to use it on any of their 5 different variations of the LIFE habitat. Now let's check in with VAST, which has been testing the domed observation window for its Haven 1 space station. The viewport measures 1.1 meters across and will provide a 180-degree panoramic view of the Earth. The dome is made of 3 key layers, ensuring structural integrity as well as protection from micrometeoroids and orbital debris. It also protects against astronauts accidentally bumping into it, and to mimic this, VAST ran simulated kick tests using hundreds of pounds of force to prove it. Beyond observation and photography, VAST hopes this centralized window will give the occupants of the station an opportunity for reflection as well as a connection with the Earth during their stay. The window is located within the station's common area, where the crew will come together to work, relax, eat and exercise. At 24 cubic meters, the area is just over half of the station's habitable volume. Haven 1 plans to accommodate up to 4 astronauts on missions lasting up to 30 days, and it's on course to become the first ever commercial space station. Vast unveiled the final design in October and revealed a full-scale replica at the 40th Annual Space Symposium in April. With maplewood veneer paneling adding natural warmth, it's as sleek in design as it is functional. DAS also actually got an opportunity to visit Vast's facilities in California last year, so if you haven't seen that yet, then I highly recommend you check that out. And of course, if you want to follow along with all of these space stations and all of the other space news, I think there should be a subscribe button down there, maybe a notification bell as well. And of course, if you like this video, why not give it a like and share it with your fellow space enthusiasts? Now let's take a look at some other stories across space, starting with SpaceX's Starship. This week, the company performed 2 static fire tests of Ship 35, the Starship upper stage, set to launch on the rocket's 9th flight. Both tests were conducted at the company's Massey's test site just a few miles west from Starbase proper. The first was a short 6-second firing of a single engine simulating an in-space relight burn, a feat that Starship Block 2 is still yet to achieve in an actual flight environment. The second static fire came the day after and saw the firing of all 6 Raptor engines on the ship for about 30 seconds. This is similar to what SpaceX did with the previous ship, Ship 34, ahead of its own flight, with the difference here being that instead of 60 seconds in duration, it was about half of that. Ship 35's test seemed to end quite abruptly and more flashy than usual. Raptor tends to put on a flame show when it shuts down, but this time there seemed to be a lot more flames than usual. As usual, we'll just have to wait and see what happens with this vehicle and whether SpaceX gives us any information about this test or not. And of course, you can expect a full rundown and analysis on the next Starbase update episode, with any updates released between now and then. NASA's Psyche spacecraft has had to power down its thrusters following a drop in xenon fuel pressure. Psyche launched on a Falcon Heavy back in October 2023, I was fortunate enough to be there, and has been on its way to asteroid 16 Psyche ever since. But on April 1st, its xenon gas pressure decreased from 36 psi to 26 psi, which triggered the automatic shutdown of Psyche's ion thrusters. Even though the propulsion systems are shut down, the spacecraft is on a safe trajectory until mid-June. Psyche is the first spacecraft to use electric propulsion with Hall effect thrusters beyond lunar orbit. To quickly summarise how these work, the thrusters use electric power generated by the spacecraft's massive solar panels to strip electrons from the xenon atoms to create positively charged ions. Then an electromagnetic field speeds up the ions to throw them out of the engine at high speed, which is how the engine produces thrust. The propulsion system is crucial to stay on course for the Mars Gravity Assist planned next year. That will put the Psyche spacecraft on a path to orbit asteroid Psyche by August 2029. Psyche's mission team has chosen to defer thrusting until they've identified what caused the issue. If it turns out that the primary fuel line is compromised, the spacecraft has 2 backup fuel lines that could be switched on if needed. You can help the James Webb Space Telescope study the universe. Well, as long as you're at least 10 years old. Webb has taken images of thousands upon thousands of galaxies, and scientists are interested in how they change shape throughout their lives. Comparing the shapes of galaxies at different distances teaches scientists how galaxies change through time. For that, they first need to classify the shapes of 500,000 galaxies. That's a massive job, and to get it done in a reasonable time, they're collaborating with citizen scientists through the Galaxy Zoo project, and you can be one of them. As a citizen scientist, you'll answer some simple questions about a galaxy in Webb's picture, but these answers can be very useful. Throughout its nearly 20-year history, Galaxy Zoo volunteers have contributed to many scientific papers, and some of them have been the first to discover new astronomical objects. Recently, Galaxy Zoo helped out the Euclid Space Telescope, and with Webb's images now on the website, there might be much more to come. Chinese commercial launch provider CAS Space has reached a significant milestone in the testing of the ground support equipment for its new rocket. The forthcoming Lijian 2, or translated literally to the Kinetica 2, was selected back in October to carry the new Qingzhou cargo vehicle to the Tiangong space station. Qingzhou is one of 2 new low-cost spacecraft that will service the station as part of China's first commercial cargo supply contracts. Lijian 2 will also carry batches of internet communication satellites to low Earth orbit as China continues to build its mega constellations. To verify that the ground support systems are ready to support this rocket, CAS Space tested a wide range of operations with a mock-up. These tests included the horizontal transportation of the rocket to and from the pad. Mechanical, electrical and hydraulic systems on the transport erector were thoroughly tested, including the vertical staging of the vehicle. The hardware also includes an elevator for the loading of cargo while the rocket meters vertical. The liquid-powered rocket measures 53 meters in height. It will be expendable at first, but there are plans to recover and reuse the first stage and its boosters by 2028. A 4-booster heavy lift version is also planned. With the latest tests completed, Lijian 2 will now move towards its maiden launch this September. Stoke Space is making progress with engine testing for its Nova rocket. This week, the company announced that it managed to get both engines to operate above 100% of the designed power levels. Nova is a fully reusable 2-stage medium-lift launch vehicle that the Washington state-based company has been working on since it was founded in 2020. Stoke wants to reuse the rocket's first stage up to 100 times. That booster is constructed out of stainless steel and powered by 7 Zenith engines running on liquid oxygen and liquefied natural gas, a different name for methane. The Zenith engine runs the full-flow staged combustion cycle, a notoriously complicated engine cycle which so far has only successfully flown with the Raptor on SpaceX's Starship and Super Heavy. Despite this, Stoke managed to develop Zenith on a very impressive timeline. Like Starship, Nova also uses hot staging to separate the upper stage from its booster, but that's about where the similarities stop. The second stage is powered by liquid hydrogen and liquid oxygen and features a rather unconventional engine. In fact, it's not just an engine, but doubles up as the heat shield that protects the vehicle through re-entry. This way, it combats the re-entry heat using the engine's regenerative cooling system. And yes, despite having 24 thrusters, the entire bottom of the second stage is technically a single rocket engine called Andromeda. A few years ago, Stoke performed some hop tests with an earlier version of the upper stage. According to CEO Andy Lapser, the next hop will be, quote, to orbit. With both engines performing well and Stoke moving at incredible speed, this might be coming up soon. This company is definitely one to keep an eye on. Now let's take a look at the very busy space traffic of the week and see what's coming up next week in spaceflight. Kicking off the week, we have the launch of a Changzheng 3B from Xichang on April 27th at 15:54 UTC. The mission was carrying the 5th Tianlian 2 communications relay satellite into geosynchronous transfer orbit. These satellites are akin to NASA's TDRS constellation, which allows ground teams to communicate with spacecraft and satellites even without direct line of sight with a ground station. This week, we also had a myriad of launches carrying internet satellites into space. The first started from Florida on April 28th at 0209 Universal time. That was with a Falcon 9 rocket carrying a mixed batch of Starlink V2 Mini and direct-to-cell satellites into orbit. The first stage for this mission was a Veteran, flying for a 20th time, and it successfully landed on SpaceX's drone ship. Just read the instructions. By the way, this mission marked the 250th dedicated flight for the Starlink constellation. Back in China, a Changzheng 5B lifted off from Wenchang on April 28th at 2010 UTC, carrying 10 Guowan internet satellites into a polar low Earth orbit. This rocket is infamous for leaving its core stage in an uncontrollable orbit, but for this mission it carried a Yuanzhong 2 kick stage, which meant no 20-ton core stages in orbit this time around. A sigh of relief from Spanish air traffic control. Just minutes after that launch at 2042 UTC, another Falcon 9 took off from Vandenberg carrying 27 V2 mini satellites into low Earth orbit. This mission saw the oldest Falcon 9 booster in the fleet, B1063, launching and landing for a 25th time, becoming the second booster to reach 25 flights. Moving east to Florida, we then had an Atlas V lifting off from Space Launch Complex 41 the same day at 2301 UTC. For this mission, Atlas was carrying a batch of 27 Kuiper satellites for Amazon's Project Kuiper. After quite the delay to get them off the ground, Amazon finally has its first batch of operational Kuiper satellites in orbit. You may remember Atlas had already flown 2 prototype satellites back in 2023, but since then, it's been radio silence from Amazon on when they would launch the operational batches. The company has a pretty busy schedule coming up if they want to keep their licensing rights with the Federal Communications Commission, as it needs to launch half of the over 3,000 satellite constellation by July 2026. Needless to say, they're probably going to need a push to the right on that deadline. And just a few hours later, from neighbouring Launch Complex 39A, another Falcon 9 took off on April 29th at 0234 UTC. It was carrying a mixed batch of Starlink direct-to-cell and Starlink V2 mini satellites into low Earth orbit. However, this wasn't your ordinary Starlink launch, as it was debuting a new booster with serial number B1094. Despite being new, it definitely had read the instructions, because it successfully landed on SpaceX's drone ship a short thought of gravity. gravitas, and I'm sure we'll see it flying again very soon. If you were keeping track of all the times and launches, that was 110 satellites for 3 different internet satellite constellations launched within 25 hours. I'm sure friend of the show and astronomer Jonathan McDowell will be very busy tracking all of them. The launch frenzy didn't end there though, as we had a Vega C launching from the Guiana Space Center on April 29th at 09:15 UTC. The mission was carrying the Biomass Earth observation satellite into a sun-synchronous orbit for the European Space Agency. Biomass is set to use a large deployable radar antenna to perform synthetic aperture radar observations of Earth's forests. This will give the scientists on Earth further insights into how much carbon they store and how it evolves over several seasons. ESA also intends to use this antenna to look at other places on Earth like deserts and glaciers and gather more data on how those also evolve over time. And to wrap up the launches in April, we unfortunately had the launch failure of Firefly's Alpha rocket. Liftoff of the rocket's 6th flight, nicknamed Message in a Booster, took place on April 29th at 13:37 UTC from Space Launch Complex 2 West in Vandenberg. The rocket was carrying a prototype satellite from Lockheed Martin using Lockheed's latest LM400 satellite bus. The ascent phase of flight for Alpha looked pretty much like all of the previous successful missions in the past. However, after main engine cutoff, a large cloud could be seen from where the rocket was supposed to be, and a few seconds later, onboard footage showed chunks of hardware flying off. Furthermore, it looked like the nozzle extension of the Lightning engine of Alpha's upper stage was completely missing. After a bit of a wobble from the visibly violent stage separation event, it looked as if everything was fine, but the big question was whether Alpha would have enough performance to reach orbit with this payload or not. As it turned out, Firefly announced after the mission that indeed it was not enough performance and the rocket and payload did not reach orbit and fell into the Pacific Ocean. With this failure, Alpha currently stands at only 2 fully successful flights out of its 6 total. However, the guidance and navigation showed that the second stage is pretty resilient no matter what you can throw at it. That Alpha launch was also the 26th and last launch of April, bringing to a close the most active April in space history. In the ranking of space launches, the US remains at the top thanks to SpaceX, which, as of the end of the month, had launched 50 Falcon 9 rockets. Barring any surprises, it looks like we'll have more than 280 launches worldwide by the end of the year, and who knows, maybe we'll cross 300 launches for the first time. At the end of the month, we also had the return of the Shenzhou 19 crew from the Tiangong space station. Following last week's arrival of the crew of Shenzhou 20, the spacecraft undocked from the station's forward docking port on April 29th at 2000 UTC to start its journey back home. On board were Commander Hai Ju-Che and flight engineers Song Ling-dong and Wang Haozi. Following a 1-day delay due to wind conditions at the original landing site, Shenzhou 19's descent capsule touched down on the desert plains of the eastern Inner Mongolia region on April 30th at 0508 UTC. During the crew's 182-day stay on the station, the trio performed dozens of science experiments and observations and conducted 2 spacewalks, one of them breaking the record for the longest spacewalk at over 9 hours in duration. This was the second flight for Ju-Che, logging a total of nearly 365 days in space across 2 missions. Ling-dong and Haozi were flying for the first time, so they now have logged those 182 days in space from this mission. Up in space, NASA astronauts Anne McCrea and Nicole Ayres performed the 275th spacewalk in support of the ISS project. The 5-hour 44-minute excursion started off on May 1st at 13:05 UTC, during which the pair relocated a communications antenna and installed a mounting bracket for a future rollout solar array. McCrea and Ayres also installed a jumper cable to carry power from the P6 truss, located on the portmost side of the station, out to the Russian side of the station. The spacewalk was preceded the day before by an unplanned reboost of the ISS by the Progress MS-30 spacecraft. This was performed due to a piece of debris from a Changzheng rocket that launched in 2005 that could have come as close as 600 meters from the station had the maneuver not been performed. Thankfully, this didn't impact the spacewalk plans at all. And to wrap up the week, we had another Starlink launch from Florida. Liftoff of Falcon 9 with 28 Starlink V2 mini satellites on board took place on May 2nd at 01:51 UTC. The booster for this mission was flying for an 18th time, and it successfully landed on SpaceX's drone ship. Just read the instructions. With the many Starlink launches this week, SpaceX has now launched a total of 8,431 Starlink satellites, of which 1,097 have re-entered and 6,591 have moved into their operational orbit. Before too long, we're going to have Kuiper stats in here too. Going into next week, we have yet more internet satellite launches with potentially up to 4 Starlink launches from all 3 of Falcon 9's launch pads. China might also launch next week the second flight of the Changzheng 12 rocket, this time carrying a batch of Guowan internet satellites. Since things in the spaceflight industry tend to be very fluid, the best way to keep up to date with all the latest launch updates is to visit nextspaceflight.com or download the Next Spaceflight app on your phone. And that's your weekly update of spaceflight news. I've been Caton for NSF, thanks for watching, and goodbye.